After studying this module, you shall be able to understand the concept of ammunitions, learn about the different components of various ammunitions, learn about the different types of propellants and primers.
According to Section 2-1B of Indian Act of 1959, ammunition means any artillery that can be used in combat or warfare. It includes 1. Rockets, bombs, grenade, and other live missiles. 2. Articles designed for torpedo service and submarine mining. 3. Other articles containing are designed or adapted to contain explosive, fulminating or fissionable or noxious liquid, gas, etc. 4th, charges of firearms and accessories for such charges. 5th, fuses and friction tubes. 6. Parts of and machinery for manufacturing ammunition. Most of the crimes committed involve use of small arms which consist of cartridges, propellants, primers, and projectiles and wads.
We shall now begin discussing about the types of ammunitions. According to Section 2(1)B of Indian Act 1959, ammunition means any artillery or firearm, and it includes A. Rocket, bombs, grenades, and other live missiles. B. Articles designed for torpedo service, submarine mining. C. Other articles containing or designed or adapted to contain explosive, fulminating or fissionable material or noxious liquid, gas, etc. D. Charges of firearms and accessories for such charges. E. Fuses or friction tubes. F. Parts of any machinery for manufacturing ammunition. Most of the crimes committed involve the use of small arms. These are arms designed for personal use. Small arms and ammunition are of two types: metallic ammunition and shotgun ammunition. Now we shall look at the different components of a metallic and a shotgun cartridge. The components of a metallic cartridges are: A. Metallic cartridge case or shell. B. Percussion cap or primer. C. Propellant or gunpowder. D. Bullet. And those of a shotgun cartridges are following: A. Paper cartridge case or shell. B. Percussion cap or primer. C. Propellant or gunpowder. D. Spherical ball or lead pellets. And E. Overshot wad, undershot wad, air cushion wad, and overpowder wad.
Now we shall learn about propellant and their types. Let us start. What are propellants? 1. The expression propellant means an agent which fires the projectiles out from a firearm. 2. In order to propel a bullet or shotgun charge through the barrel and air, a certain amount of force is necessary. The powder charge gets ignited through primer and converts it into the gas very quickly, thereby resulting in development of high pressure in the cartridge and forcing the bullet to get out of the barrel. The three types of propellants used are gunpowder, which is also called black powder. Number two, smokeless powder. Number three, semi-smokeless powder. Gunpowder is the oldest recorded propellant and had been invented by Chinese around the 10th century. It was used for giving signals and fireworks. The gunpowder consists of potassium nitrate, sulfur, and charcoal, roughly in the proportion of 75 as to 15 as to 10. The powder is not suitable for high velocity ammunition as large amount of powder would be required for getting high velocities for the projectiles. The powder leaves considerable amount of solid residue which tend to foul the barrel. It remains fairly stable if kept dry over a long period. It is glazed and polished to increase its storing or keeping quality. Gunpowder causes much smoke and fouling of the target. It is mostly used in muzzle loading and blank cartridges. The powder is available with different grain sizes from match limit 6 to 10 to 46 to 60, and they are designated capital E small g and capital F, capital F, capital F, capital F small g respectively. Smokeless powder. The modern high velocity era started with the use of smokeless powders. The basic constituent of the smokeless powders are nitroglycerin and nitrocellulose, which is also called gun cotton. Nitrocellulose is either used alone or in combination with nitroglycerin to form propellants. The latter are called double base powder, while the former is known as single base powder. Some of the double base powder commonly used and having constituents, namely nitroglycerin, nitrocellulose, and mineral jelly, are credite, modified cardite, and ballistite. The composition of common double base powder is detailed below. Cardite has 58% nitroglycerin, 37% nitrocellulose, and 5% mineral jelly. Modified cardite has 30% nitroglycerin, 65% nitrocellulose, and 5% mineral jelly. Ballistite has equal quantities of nitroglycerin and nitrocellulose without any mineral jelly. Smokeless powder deteriorates with time. However, the lifespan of such powder has been increased tremendously by improved technology and by addition of stabilizers. It is important to note that smokeless powders do not explode inside a cartridge. Instead, they combust. Since the combustion is occurring in a closed space, it can have the force of an explosion. Semi-smokeless powder. Semi-smokeless powder is mixture of black powder and nitrocellulose. The approximate composition of the powder is nitrated wood cellulose 20%, potassium nitrate 60%, carbon 12%, sulfur 8%. This powder produces less smoke than gunpowder, but mixing process is quite dangerous. The danger involved in its production has prevented its extensive production and use. Triple based powder. The triple based powder contains nitroglycerin, nitrocellulose, and black powders. The percentage of the various constituents vary but do not offer any special advantage, hence seldom used. RDX based propellant. A new propellant in which the active ingredient is from the family of cyclotrimethylene triamine, that is RDX, has come up. It is being utilized in the manufacture of cartridges by controlling not only the shattering nature of the high explosive but also its heat production. The advantages are obvious. The rate of fire can be increased without detrimental effect on the weapon firing the ammunition. However, its composition and other details are not available presently. An ideal powder should have features like it should be stable on storage, it should not be corrosive, it should produce minimum amount of smoke, it should produce minimum amount of heat for a given velocity, it should be homogeneous, some amount of the powder should give same velocities. It is mainly to improve these qualities that most of the research on propellants is being done. In addition, reduction of production cost and increase in safety margins are other important considerations. Consequently, new propellants are always lined up in the market.
Now let us discuss about propellants. The expression propellant means an agent which propels out a bullet from the firearm. It is explosive in nature such that it fires the projectile from the gun. In order to propel a bullet or shotgun charge through the barrel and air, a certain amount of force is necessary. The powder charge gets ignited through primer and converts it into gas quickly, resulting in development of high pressure in the cartridge and forcing the bullet to get out of the barrel. Further, three types of propellants are generally used: A. Gunpowder or black powder, B. Smokeless powder, and C. Semi-smokeless powder. Now we shall discuss about gunpowder. Gunpowder is the oldest recorded propellant and was invented by Chinese around the 10th century. It was used for sending signals and fireworks. The gunpowder consists of potassium nitrate and sulfur and charcoal roughly in the proportion of 75, 15 and 10. The powder is not suitable for high velocity ammunition as large amounts of powder are required for getting high velocities of projectiles. The powder leaves considerable amount of solid residues which tends to foul the barrel. It remains fairly stable if kept dry over a long period. It is glazed and polished to increase its storing or keeping qualities. Gunpowder results in much smoke and fouling of the target. It is mostly used in muzzle loading and blank cartridges. The powder is available with different grain sizes from mesh limit 6 to 10 to 46 to 60, and they are designed as FG and FFF-FG respectively. Smokeless powder. These are used in modern high-velocity ammunitions. The basic constituents of the smokeless powders are nitroglycerin and nitrocellulose, that's gun cotton. Nitrocellulose is either used alone or in combination with nitroglycerin to form propellants. The latter are called double base powders, while the former is known as a single base powder. Some of the double based powder commonly used are having constituents named nitroglycerin, nitrocellulose, and mineral jelly. The components of common double based powder is as follows. Cordite has 58% nitroglycerin, 37% nitrocellulose, and 5% mineral jelly. Modified cordite has 30% nitroglycerin, 65% nitrocellulose, and 5% mineral jelly. Ballistic has equal quantities of nitroglycerin and nitrocellulose without any mineral jelly. Smokeless powders deteriorate with time. However, the lifespan of such powder has been increased tremendously by improved technology and by addition of stabilizers. Also, they do not explode inside a cartridge. Instead, they combust. Since the combustion is occurring in a closed space, it can have the force of an explosion. Now let us talk about semi-smokeless powders. Semi-smokeless powder is a mixture of both black powder and nitrocellulose. The approximate composition of the powder is nitrated wood cellulose 20%, potassium nitrate 60%, carbon 12%, and sulfur 8%. This powder produces less smoke than gunpowder, but mixing process is quite dangerous. The danger involved in its production has prevented its extensive production and use. Let us now discuss about triple-based powders. A triple-based powder contains the following ingredients: nitroglycerin, nitrocellulose, black powders. The percentage of the various constituents vary but do not offer any special advantage, hence seldom used. Another type of propellant used is the RDX-based propellant. In this active ingredient from the family of cyclotrimethylene triamine, that is RDX, is used. It is being utilized in the manufacture of caseless cartridges by controlling not only the shattering nature of the high explosive, but also its heat production. The rate of fire can be increased without detrimental effect on weapon firing the ammunition. After discussing about various types of propellants, we shall now conclude what properties should an ideal propellant have. An ideal powder should have the following features. It should be stable on storage. It should not be corrosive. It should produce minimum amount of smoke. It should produce minimum amount of heat for a given velocity. It should be homogeneous, that is, the same amount of the powder should give same velocities. Let us discuss about another important component of ammunitions, that is, the primer. In firearm ballistics, a primer is a component of a firearm which, upon being struck with sufficient force, reacts chemically to produce heat, which ignites the main propellant charge and fires the projectile. The primer composition has the following basic ingredients: an initiator, a sensitive high explosive, may be lead stiphanate, lead azide, silver stiphanate, or silver azide. Fuel. Generally, antimony sulfide is used. An oxidizer, a source of oxygen. Here, barium nitrate is necessary to bring about combustion. A stabilizer, the sensitive high explosive which functions as an initiator, is a pressure sensitive material which gives out a flame to ignite combustible material which work as a fuel. An oxygen supplier would supply necessary oxygen so that combustion of fuel is proper. A friction causing material is also mixed to carry out the functioning of the entire exercise in a satisfactory manner. In 1807, a Scottish clergyman, James Forst, discovered a shock sensitive explosive called mercury fulminate. This type of explosive will detonate if it is stuck or shot. A spark will also be generated. By 1850, cartridges that were being manufactured contained mercury fulminate inside the rim of the cartridge. The composition of mercury fulminate primer by weight is as follows. Mercury fulminate 8 parts, potassium chlorate 14 parts, antimony sulfate 18 parts, sulfur or glass 1 part, gunpowder 1 part. In spite of being a shock-sensitive primer, mercury fulminates suffer from a number of drawbacks. Mercury fulminate gives mercury on ignition. It makes the brass case brittle and consequently unfit for frequent use. Barrels get deteriorated quickly because of the deposition of mercury in them. Potassium chlorate, when ignited, produces potassium chloride which absorbs moisture, resulting in rusting of barrels early. Powder glass particles, if used, will abrade the barrel, resulting in the increase of bore diameter. Now let us discuss about wads. A wad is a disc made by folding or rolling paper and is used to hold in place the powder and shots in a shotgun cartridge. These are of various types like over powder wad, cushion wad, undershot wad, and overshot wad. They keep the charges in the cartridge in their proper places. In addition, the cushion wads seal the barrel on firing and prevent escape of gases and consequent loss of velocity. The cushion wads are about 12.5 mm thick. They also clean and lubricate the barrels. Overpowder, undershot, and overshot wads are made of special quality cardboards varying in thickness from about 2 to 3.5 mm. They are waterproof. They are slightly larger than the bore of the firearm for which they are intended. To increase the efficiency of shotguns, several modifications in wadding has been done, like the base wad is plastic mold and fixed in the base of the brass head under pressure. The overpowder wad has changed to an inverted cup wad, open side towards and over the powder, so that when gases are formed, the open round edge of the cup is pressed with the pressure against the barrel and thus it seals the bore. It prevents the escape of gases from the sides. The cushion wad's function is carried out by the cup wad and piston, which is attached to the rectangular projectile sleeve containing and protecting the projectiles from coming in contact with the barrel and consequent damage. The sleeve has cuts along the edges in frontal part of the sleeve. The four sides of the sleeve open up and fan out along the cuts when the sleeve comes out of the muzzle. The sleeve gets separated from the projectile charge. The sleeve being lighter falls down. It does not interfere with the shots in their flights. The buckshots in cartridge have spaces which are filled with granular plastic materials to cushion the buckshots. The plastic granular material prevents damage and provides uniform push to the projectiles. The ensured proper push to the projectiles gives better spread and uniform velocities to the buckshots. The above innovations has improved the aim, range, and ballistics of the shotgun cartridge considerably. Let us learn about cartridge cases. Cartridge case is also known as an empty case or a shell. It provides housing for various components of the cartridge. It is usually made of brass for rifle, pistol, and revolver ammunition. For shotgun cartridge, case is made from several layers of paper which are tightly compressed. The base of this paper shell is made of brass. Plastic shells for shotgun are also being manufactured now. Cartridge cases for low velocity weapons are shot with parallel walls. These cartridge cases, which are meant for high velocity weapons, are long and bottle-necked. The base of the cartridge case may be rimmed or rimless.
Let us try to remember few important points that we learned in this module. According to Section 21B of Indian Act of 1959, ammunition means artillery that can be used in combat or warfare. It includes rockets, bomb, grenade, and other live missiles. Articles designed for torpedo service and submarine mining. Other articles containing are designed or adapted to contain explosive, fulminating or fissionable material or noxious liquid, gas, etc. Charges of firearms and accessories for such charges. Fuses and friction tubes. Parts of and machinery for manufacturing ammunition. In simple words, ammunition means any artillery that can be used in combat or warfare like bombs, rifle, guns, machines, etc. Ammunition not only includes the different types of arms used, but also deals with the different components in an ammunition. That is, primer, propellant, cartridge cases, etc. Most of the crimes committed involve use of small arms which consist of cartridges, propellants, primers, and projectiles, as well as wads. In order to propel a bullet or shotgun charge through the barrel and air, a certain amount of force is necessary. The powder charge gets ignited through primer and converts it into gas very quickly, thereby resulting in development of high pressure in the cartridge and forcing the bullet to get out of the barrel. The three types of propellant used are gunpowder, black powder, smokeless powder, and semi-smokeless powder. These are three different types of gunpowders. Black powder being the primitive of all. Nowadays, smokeless powders are used in modern ammunition since they emit less smoke and hence lesser unburnt propellant is left behind. An ideal powder should have the following features. It should be stable on storage, it should not be corrosive, it should produce minimum amount of smoke, it should produce minimum amount of heat for a given velocity, it should be homogeneous, same amount of powder should give same velocities. Wads form an important part in a shotgun as it helps perfecting the shots. Depending upon the type of shotgun, different type of wads are used like cushion wad, overshot wads, undershot wads, etc. Several types and constituents of cartridges cases are available according to the type of ammunition used.
Let us now summarize what we have learned in this module. Ammunition means any artillery that can be used in combat or warfare, like bombs, rifles, guns, machine guns, etc. These not only include the different types of arms used, but also deals with the different components in an ammunition, vis-a-vis primer, propellants, cartridge cases, etc. There are different types of gunpowders, black powder being the primitive of all. Nowadays, smokeless powders are used in modern ammunitions, since they emit less smoke and hence lesser unburnt propellant is left. Wads form an important part in a shotgun as it helps in perfecting shotgun shots. Depending upon the type of shotgun, different type of wads are used, like cushion wads, overshot wads, undershot wads, etc. Several types and compositions of cartridge cases are available according to the type of ammunition used.